Okay, so this is section 1.6, and we're going to talk about solving first degree equations, meaning that we have equations that just have a power of 1. So we have a variable and it's just being raised to a power of 1. We want to show how to do this with single step and multi-step equations, and then we will apply equations to some real life examples. All right, so single step equations are something that you have seen many times in your academic career, but I just want to make sure that I touch on it just so you kind of have an idea and get refreshed. So the goal anytime that we have an equation that we need to solve for a variable, we want to isolate the variable, meaning we want to get the variable by itself. Usually we try to move the variable to the left, or keep it on the left side of the equal sign. That is not always necessary, but it is always possible to do that. So for these, single step just means it takes us one step to solve it. So I'm going to, for this first one, I want to just subtract 5 from both sides. That leaves me with x is equal to -1. So again, I isolated x, and then I just found that x would be equal to -1. If I wanted to check that, then I could just plug -1 back in for x. So -1 plus 5 would be equal to 4. So we undo addition with subtraction, same way we would undo subtraction with addition. And then we undo multiplication with division. So over here on my second example, if I want to divide that by 2, then 2 divided by 2, you can cross those out. 8 divided by 2 is 4. So again, I could check that. 2 times 4 is 8, so therefore x would just be equal to 4. And now multi-step equations means that it takes more than one step to solve. It could be, it could be 2 steps, it might be 5 steps, right? But I kind of want to think about this in a way of PEMDAS backwards. Okay, so if I'm thinking about it in a PEMDAS backwards, then that means that addition and subtraction would come first. So that's what I kind of want to get rid of. So for this first example, to undo a -3, I would just add 3 to both sides. And that leaves me with 5x is equal to 21. Now I can undo multiplication, so the 5x, if I just divide both sides by 5. And x would just be equal to, so 21 over 5 is not a clean number. Or what, I mean, it is a clean number, but it is a decimal. So I can just leave that as 21 over 5, and that is perfectly okay to do. So my final answer would be 21 over 5 for x. Again, I could check that by plugging it back in for x and confirming that both sides are equal. Now my second example here, it does take a few more steps to do. So the thing that I would tell you to do is go ahead and simplify both the left and right as far as you can simplify it, and then basically clean it up, and then you can start applying your steps to solving the equation. So I have 2k. I'm going to go ahead and distribute the 3k, or the 3. So I have 3k minus 12, and that is equal to 2k minus 6. Okay. So I went ahead and I expanded, but now I want to simplify. So 2k plus 3k is 5k minus 12 is equal to 2k minus 6. So now by doing this, that will allow me to solve my equation. And so I'm going to go ahead and move the k's over to the left by subtracting 2k. And then, so that leaves me with 3k minus 12 is equal to -6. Now I can add 12 to both sides. That leaves me with 3k is equal to 6. And then just divide. So divide both sides by 3. So then K is, I'm going to come over to my left here. So K is now equal to 2. So that would be another example of solving a multi-step equation. Again, just clean it up first by, maybe expanding it out, maybe simplifying it, maybe doing both, and then that will allow you to do your steps. Okay, so now if I have fractions, all right, so I have a multi-step that involves fractions, and to add or subtract anything, again, I need a common denominator. All right, so an easy way to find a common denominator with this is write out the multiples of each of these different denominators. So for an example, let's say I'll start with the biggest one. Let's start with 20. So I would go 20, and then 40, and then 60, and then 80. Okay, so all I'm doing is just increasing by 20. Now let's go to 15. So if I have 15, I have 30, I have 45, I have 60. Okay, now let's go to 10. So I have 10, 20, 30, 40, 50, and 60. So I do have 60 in common with all three. And so 5 will definitely go into 60 because 5 goes into 10, it goes into 15, it goes into 20. So 5, 10, 15, and then I'm just going to skip a few down to 60. So that would be my it's called the least common denominator, but this would be my new denominator, 60. But remember, whatever I do to my denominator, I also have to do to my numerator. Okay, so to make 10 into 60, I had to multiply it by 6. So that means I have 6r over 60. Okay, to make 15 into 60, I had to multiply it by 4. So I have 8 over 60. So I did 2 times 4. To make 20 60, I had to multiply it by 3. So that's 9r divided by 60. And then to make 5 into 60, I had to multiply by 12. So 12 times 1 is 12 divided by 60. So now I can just do my steps for solving. Okay. Now I am allowed to multiply both sides by this denominator, and it will not change the result. So I can multiply both sides by 60. And so now that gets rid of my denominator. So now I can just focus on my numerator. Okay. So I just multiplied through by 60. That got rid of the denominator. So now I just want to focus on my numerator. And I can solve this the same way that we've been solving all of these multi-step equations. So I'm going to subtract 9r, subtract 9r. So that leaves me with negative 3r minus 8 is equal to negative 12. Now I want to add 8 and add 8. So that leaves me with negative 3r is equal to negative 4. Now we don't like it, our variable to be negative. So to come up here, and I would want to, so I have negative 3r is equal to negative 4. So then I could just divide by negative 3, divide by negative 3. That leaves me with r is equal to 4 over 3. And so this concludes the video on solving single and multi-step equations. And we will use this in the application process, but we will do that in a later video. If you have any questions, please email me, and have a great rest of your day.